In this new video, we are going to cover a somewhat advanced topic called component port delegation. To illustrate this, we will take an extract from my Capella training with the EOLE model, also presented in the first book on Capella. The example is located at the level of logical architecture, but could also have been located at physical architecture level. Remember, delegation of component exchanges is an important and difficult topic related to encapsulation and modularity of your model. So now I want to focus on the external parts of the logical system, but because for the EOLE system, and it's not always the same, you can maybe have to build a system which in the end, even at physical architecture, will be a big unique box with a lot of components inside, like the car radio set, for instance. Okay. For EOLE, in the end, we will have balloons in the sky and ground stations on the ground. We will not have a big box around. Okay. So in fact, from the logical architecture level, we can already say that the logical system is just there to remind us of the external interface of the system at system level, but we will have to move the ports that are at the boundary of the logical system to the right subsystem. In the end, there are two subsystems interacting. So in fact, because it's the case for our EOLE project, I recommend that you change the color of the logical system to put it white, because in fact, the important components are acquisition and ground, and logical is just a reminder. And even we could hide the label of the logical system just to show some white rectangle like this. And the important things are the two subsystems with the logical components inside. And here, if you put it in white, you maybe realize more clearly that these ports here should not be any longer on this sort of ghost boundary, but that you have to move the ports to the right component. So here, typically, we can do this, and we can do this. Okay, the measurement engineer will send command to the acquisition subsystem. The atmosphere provides the environmental conditions to the acquisition subsystem. So on the left part is very simple. You just have to move the ports to the right logical component. On the right part, it will be a little more complex. So I show you. First, we have to do the same. Everything goes, in fact, to the ground subsystem. So now the external actors, they will talk directly to the ground subsystem. But then, as I showed in a previous PowerPoint slide, the ground subsystem itself has to delegate the output or input things to the right subcomponent. Of course, we are helped by the functional exchanges. Okay, the functional subscription interface are functional exchanges between these two functions. So in fact, this subscription interface should go here. But now, methodologically in Arcadia, we can do two different things. We could do a very simple one, which consists in moving again the port directly to the publication manager. Publication interface, output to the publication manager, and so on. That's possible in Arcadia. But it would mean that the ground subsystem as a component has no real external interface. But if you really want to be able to show the ground subsystem with its ports, external ports, because at physical level they will exist. So the ground subsystem at physical level will be some ground station with walls and so on. Maybe it's better, so I undo. Maybe it's better, I undo. In fact, it's better in this case to use a more subtle thing, especially if you go back to this input-output port, because in fact, in the forecaster UI, okay, so on the LAB, let's apply the same show allocated functional exchanges and component exchanges filter, refresh the diagram. Okay, so we understand better maybe that current situation is going from here to here. So we would need some output port here, whereas the weather forecast goes here to be published. So we need an input port here. So we cannot really move this to one or the other because this one has to be moved to the ground subsystem, but then has to be delegated to both. So here it's really better to do it the second way that I will show you now. We will use a more advanced way to do it. So in the palette on the right, you have to go to component exchange, but in fact, there is a little arrowhead here. If you click on it, you have additional commands. I recommend that you pin it open with a little pin button here, so that each time you select something, it doesn't collapse again, showing the last activated thing first. So the one that I will use now is delegation. And if you can read what Capella says, it creates a component exchange of kind delegation between a port of the parent component and a port of a sub-component. That's exactly what we want to do. We want to create some delegation from a port of the parent component to a port of a contain component. So we will use the delegation tool now. I show you how to do it. For instance, it's interesting to do it from the output port of the ground subsystem. So you have to zoom enough because ports are very small, and you have to be really near the port you want to delegate. You click again and you release inside the contained component, and you click again. It will create a new port and something that is called, it's a component exchange of type delegation. In fact, it's a kind of component exchange, this one, like this one. This one is a normal component exchange of type flow. Okay, they try to use the SysML words, assembly and flow, which have no real meaning in Arcadia and Capella, so it's a flow. And the other one is a delegation. This one is a delegation. And the very important thing is that when you create a component exchange, Capella automatically creates an output port and an input port in the direction of your movement. When you create a delegation, if it is an output port on the parent component, it's mandatorily also an output port on the contain component. Capella knows it. Because it's a delegation, ports have the same direction. Whereas on a component exchange, ports have opposite directions. Okay? So I do it again. Delegation from this input port to publication manager. Okay, it was nice for the layout. This time it's not nice at all. So here probably I should put it rectilinear. Yes. And once again, it was an input port on the ground subsystem. It's mandatorily an input port also on the publication manager. I didn't start with this port because this port is bidirectional, so it's less obvious to understand that it keeps the direction, because if it's bidirectional. And the most interesting one is this one, because this one you have to delegate twice. First here, yes, but in this case you just need, remember, the current situation is going out. If we show the functional exchanges, it goes from elaborate to forecast weather. So this one should be an output. It should only be an output port. Doesn't need to be input at the moment. So here, remember, it's the component ports that bear a direction. So this one, I just double click. By default, Capella kept the in-out direction, but in fact, it can be just out. It's enough. And then to show you another way to do it, I will manually create a port here. It's possible to create a port on a component. This time it's in. The weather forecast is going inside the publication manager in flow port. And now I just have to delegate again from the same container port to this one. I directly point to the existing port instead of creating a new one, so that I'm sure that it's an input one. Okay, so if you do it very precisely, you can create delegations between existing ports. So this bidirectional port is delegated both to an input port of publication and to an output port of data processing manager. Okay, so first I check that I have no longer any port on the logical system. And then, because this one is broken down into sub-logical components, I had to work a little on the delegation. And I'm just missing now that there is a functional exchange from acquire to elaborate. So I should have an output port on acquisition, a component exchange, and an input port on the ground, and some delegation from the ground subsystem to the data processing manager. So instead of creating first a component exchange and then the delegation, I have a specific command, which is component exchange with delegations, which will do everything in one click, in fact, because Capella knows whether we cross the boundaries of containers and contain components. So if you use this time, not the delegation tool, but the component exchange with delegations, you can go from acquisition subsystem directly to inside the data processing manager, and it will create the necessary delegations. Okay, let's do it. Up. You just have to move it smoothly like this. So it has created in one click, one output port, one component exchange, one input port, one delegation, one input port. Nice. And we just have now to rename the component exchange that we just created and allocate the functional exchange that is possible. And Capella will only propose the relevant ones. So let's double click on the component exchange. So it's acquisition to ground interface, acquisition ground interface, and then in the allocated functional exchanges field, Capella will propose me all the functional exchanges that cross the boundaries of these two things. And there is, in fact, only one. So even if you have the filters, you will not make mistake because Capella will propose the right ones only. Yes. Okay, because it's the same filters. So this is the completed LAB. Okay, so now again, I could show you the SAB and the SAB and the LAB together, just to show you the difference. So we have the same external actors, but now inside the system, instead of having a black box with just 4 functions, now we have created logical components, sub-logical components, and we have started to refine the functional allocation. We could have gone further, of course. So now what I would like to show you, and I double click to see again the Project Explorer. So by the way, at logical architecture level, now you see the delegations, the little delegations here. Okay, it's called D6, D1 in the order of creation, D1, D2, probably D3, D4, D5, D6, something like that. So as the delegation is a sort of component exchange, because we see the component exchanges. These are the external component exchanges connecting the logical system to the external actors. Then you have the internal component exchange acquisition ground interface between the two subsystems, and then you have the delegation inside the ground. Okay, Capella automatically puts the model element at the right location in the containment tree.